These are the lesson 13.4 notes on the sine function. Today we're going to look at parts of the sine function, equations of sine functions, and graphs of sine functions. You may recall, if you're talking about sines and cosines on the unit circle, that as we move counterclockwise around the unit circle, the sine is the y-coordinate at these different angle measurements. And what you'll notice is as we move counterclockwise around this unit circle, the y-coordinates go from 0 all the way up to a height of 1, and then the y-coordinates get smaller and smaller as they head back down to 0. Then as you move around the circle, they become negative down here and then work their way back up to 0 again. The graph that you see over here on the right side does the same thing. It begins with y values that get bigger and bigger, and then they get smaller and smaller as they hit back to 0. Then the values go negative, and as we come back to 2 pi, one full circle, they end up back at 0 again. So this y values that go up, down, and back up again are modeled by this circle, where the y values go up, down, and back up again. So what you see at the right is the graph of the sine function, y equals sine of x. The amplitude of this graph is the vertical distance from the center of the graph to the highest point. We typically measure the amplitude basically from here straight up to the highest point. So this is what we call the amplitude, which is 1. Amplitude is always a positive value. Amplitude is not the height of the entire shape, as that would go all the way down to here, and that height would be 2. So we just say the amplitude is half of that height, which is 1. A cycle is a repeated path made by a sine curve. On the graph at the right, the sine curve completes one full cycle between 0 and 2 pi. So when we talk about a cycle, we're talking about kind of this S shape that goes up, down, and back up again. This is the length of one cycle right here. A period is this length of one cycle. On our graph, the period is equal to 2 pi, because that's how long it takes from left to right to get from our starting point and to complete this kind of S shape, which repeats over and over again. Now what we're going to take a look at are two different sine curves that have different amplitudes, periods, and numbers of cycles from 0 to 2 pi. For example, on our first graph, you can see that the amplitude of this graph, if we measure it from basically kind of its midpoint straight up, appears that the amplitude is a little bit past 1, probably 1.5. The period of the graph is the length of one cycle, the length of time it takes to complete one of these big old S shapes. This graph completes an S shape as we go from 0 to 4 pi. So 4 pi is the period of the graph. The number of cycles the graph completes between 0 and 2 pi, well, it completes half of a cycle. It makes a full cycle at 4 pi, so it's completing half of a cycle here. What I'd like you to do is I'd like you to find the amplitude, period, and number of cycles for the second graph. Pause the video, we'll see what you get in just a moment. So in our second graph, you can see that the amplitude of this graph is equal to 2, because if you go from the center line straight up 2 units, you get to the highest point. You could also go from the center line down 2 units to get to the lowest point, so the amplitude is 2. The period is the length of one of these cycles. A cycle is, again, kind of this S shape here, and it goes from 0 to pi, so pi is the period. And the number of cycles between 0 and 2 pi, this graph completes one full cycle, and then it completes another full cycle, so that'd be a total of 2 cycles between 0 and 2 pi. Now, what we haven't come up with yet are equations for these graphs. And the equations for these graphs are set up using this general form equation, y equals a times the sine of b times theta. A refers to the amplitude. Now, if the graph kind of starts by going up, then down, then back up again, you would consider a to be positive. If it's negative, the graph would start down and then come back up and go down. So the absolute value of a is the amplitude, where a is not equal to 0. B is the number of cycles the sine curve completes in the interval from 0 to 2 pi, and theta is sort of like our x variable. It represents an angle measured in radians. So for our first equation, we're going to go y equals, a is the amplitude, which is 1.5, and the graph goes in the positive direction. It kind of goes upward first, so it's going to be a positive value here. Sine, b is the number of cycles the graph completes between 0 and 2 pi, that would be 1/2 right here, times theta. And a lot of times you can put this value here in parentheses. Same idea for the second equation, y equals the amplitude. We're going to use 2. It goes upward, so you can use a positive 2. Sine, number of cycles is 2 times theta. And that would be your equation that generates this graph. In addition to these facts that we just talked about, there's one additional piece that we're going to add to this. Here's our same data again with our general form. In addition to these three facts here, the period of the sine curve is equal to 2 pi over b. Now, we're going to look at two examples of giving an equation for a sine curve with characteristics, and we're going to graph these as well. In our first example, we have an amplitude of 3 and a period of pi over 2, and we're trying to find an equation. The equation we're going to start with is y equals, we'll use 3 for a, that's kind of your amplitude, sine. Now, the period is equal to 2 pi over b. So our period of pi over 2 is equal to 2 pi over b. If you want to, what you can do is you can actually say the period, pi over 2, is equal to 2 pi over b. And what b represents is this value right here. It's going to be sine of b times theta. So to solve for b, you could find common denominators, or you could cross multiply. If you cross multiply here, you're going to get pi times b equals 2 times 2, which is 4 pi. And if you divide both sides by pi, you'll get b equals 4. That's the value that goes here. To make a graph of this function, I'm going to draw my horizontal right here, vertical axis here. Our graph is going to complete 4 cycles between 0 and 2 pi. So I like to usually show 2 pi as a value on my curve. Here's 1 pi. Halfway to pi is going to be 1/2 pi, which you can call pi over 2. And between half and 2 is 1.5, which you can write as 3/2, or 3 pi over 2. When you graph this function, its amplitude is 3, so we're going to go up 3 units and down 3 units. Our graph is going to go here, and it's going to make a complete cycle between 0 and 2 pi. So it needs to come to its highest point, its lowest point, and back up here again. And it's going to make another one of these S-shapes between pi over 2 and pi, in this interval and this interval as well. So it's got to come up, down, and back up again. Now it's going to cross halfway between 0 and pi over 2 at pi over 4. So this graph is going to come up, down, and back up again. And then it's going to continue to cross halfway between these intersection points. Up, down, and back up again. Halfway in between these points. Up, down, up again. Halfway between these points, up to 3, down, back up again. For our second graph, we're going to come up with an equation here for y equals, the amplitude is 1, sine. Period is 2, not 2 pi, but 2. So here we're going to make 2 equal to the formula for the period, which is 2 pi over b. Our goal is we want to find b that we can plug into our value here is going to be b times theta. This is based off of our equation up here. 2 is like the fraction 2 over 1, so when you cross multiply, it's 2 times b equals 2 pi times 1, which is 2b equals 2 pi. Cancel out a 2 from both sides, and you get b is equal to pi. Pi is the number of cycles the graph completes between 0 and 2 pi, so it completes 3.14 cycles between 0 and 2 pi. Now, honestly, that could be kind of hard to graph. So here's maybe an alternative solution here. Amplitude is 1, so we'll go up 1 and down 1 on the vertical axis. The period is 2. The period is the length of one cycle. So I'm okay here actually graphing the values 1 and 2. This is like 1 and -1. And this graph is going to complete one cycle. It's going to make one complete S between 0 and 2. So it's going to cross the x-axis here. It's going to come back, finish the cycle here. It's going to start here. It's going to go up, down, and back up again. Now if you took this all the way out to 2 pi, it would complete 3.14 cycles between 0 and 2 pi. Final thing we're going to do here is we're going to graph a cycle of each sine curve, identifying the amplitude and period. I'm going to start with my axes here. This problem, it says -2, so our graph is going to continue to have an amplitude of 2. But this time it's going to go down, up, and down again. So it goes kind of the opposite direction that our other sine curves did. 3 is the number of cycles the graph completes between 0 and 2 pi. If you wanted to actually calculate what the period is, or the length of one cycle, you could calculate 2 pi over b. And if you do 2 pi over b, you get 2 pi over 3. That's actually the length of one cycle. So if you just want to take it out to what this period is, you can show that this graph starts here. It's going to come down, back up, and then down again at 2 pi over 3. So it's going to go down to its lowest value at 2, up, and back down again. Notice on all these graphs, what am I looking for on the horizontal axis? I want to see where the period is. So if the period is pi over 2, I should at least see that value on your graph. If the period is 2, I should see the value going through 2. If the period is 2 pi over 3, I want to see 2 pi over 3 labeled on your graph. The amplitude of this graph again is 2. It's the absolute value of A, so it's the absolute value of negative 2, which is 2, and the period is 2 pi over 3. What I'd like you to do is I'd like you to pause the video and see if you can come up with the amplitude and period of this graph as well as a sketch. We'll see what you get in just a moment. First of all, you notice that there's no value in front of sine. That means we can assume there's a 1 out in front of this, and that is your amplitude because it's the absolute value of 1, which is 1. The period of this graph is 2 pi divided by b. b is 1/4, so we take 2 pi over 1/4. When you crunch that out, whenever you divide by a fraction, you multiply by its reciprocal, so 2 pi times 4 over 1 is equal to 8 pi. So when you graph your sine curve, we want to make sure that this period, 8 pi, appears on your graph. You'll notice for all 4 of these graphs, the period of the graph, the length of one cycle, appears here. Pi over 2 is on this graph, 2 is on this graph. On our other graph, we had 2 pi over 3, and on this graph, we'll have 8 pi. So halfway between 0 and 8 pi, it's going to cross the horizontal axis again, so the graph's going to come up, down in the middle through 4 pi, and back up again. If you want to put little dots kind of up here and down there to help you graph this, that's fine. And your graph should look something sort of like this graph right here. This is your graph of sine of 1/4 theta, and now you have hopefully a better understanding of how to graph equations of sine functions and how to evaluate their equations.